In this video, we're going to prove the following. If this set here is an orthonormal basis for Rn, and V is any vector in Rn, then V can be written this way, where the C sub I is U dot Vi. Of course, I is from 1 to n. So here's how you would prove such a theorem. Since S is a basis for Rn and V is in Rn, then there exists scalars A1 through A sub n such that V is equal to A1u1 plus A2u2 all the way up to ANUN. Did not mention one word about S being an orthonormal basis. It's a regular basis. Okay, it's the special basis, but nonetheless, it's a basis. So I can write V as a linear combination of the vectors in S. Now, they're telling me that this should be V. Okay, let's see if it's true. Maybe it is, maybe it isn't. c1u1 plus c2u2 all the way down to cnun. Well, c1 is v dot u1 times u1 plus v dot u2 times u2 all the way down to v dot un times un. But I have another way of writing v. It's right here. So we have v a1u1 plus a2u2 all the way down to ANUN. That's V, and it's supposed to be dotted with U1 and then multiplied by U1. Okay, plus V, which is A1U1 plus A2U2 all the way down to ANUN. That's V, and I dot this with U2, and I multiplied that scalar by U2. Plus all the way down to V, which is A1 U1 plus A2 U2 all the way down to AN UN. That's V dotted with U sub n times U sub n. But remember, this is an orthonormal basis. AI dotted with AJ equals 0 if I is not J. And if I is J, that is AI dotted with AI, it equals 1. That's the property of an orthonormal set of vectors. Okay, so let us look at this dotted with that. Well, let's write it out longhand. This is, oops, let's stay yellow. This is A1U1, oops, dotted with U1, plus A2U2 dotted with U1, all the way down to AN plus ANUN dotted with U1. And this result is all times U1 plus this dotted with U2, A1 U1 dotted with U2, plus this dotted with U2, A2 U2 dotted with U2, all the way down to ANUN dotted with U2. And that whole mess gets multiplied by U sub 2. Plus this dotted with UN, A1U1 dotted with UN, plus A2U2 dotted with U sub n, all the way down to this dotted with UN, ANUN dotted with UN, and this all gets multiplied by U sub n. Okay, so now everything comes together. This dot product is 0. This dot product is 0. The only one that isn't 0 is U1 dot U1, which is 1. So what's in these brackets is A1 times 1, which is A1, plus a lot of zeros. So we get A1 times U sub 1, plus this is 0, this one is 1, and all the other dot products is 0. So you just get A2 times 1 plus a lot of zeros. Well, that's A2. A2 times 1 is A2 times U sub 2. All the way down to the last sum. Well, that's 0. That's 0. This one is 1. So you have a lot of zeros plus AN times 1, which is A sub n. And that A sub n gets multiplied by U sub n. And this vector, this right here, that's exactly how I define V. That's exactly how I define V. So this equals V. In particular, this equal this, which equals this sum, which equaled this mess, which ultimately equaled this, which equals V. This top line is V. But that's all I was asked to show. I was asked to show that, let me just go up a little bit more. I was asked to show that this is V. And I just showed it. This is equal to what I have at the very, very end of a long string of equal signs, which was V. As a result of this, I don't know why it's being finicky here, but as a result of this, this theorem has been proven. If you like theorems like this, it's in your best interest to subscribe to my channel. All I do here is prove theorems. If there's a theorem you'll like for me to prove, leave it in the comment section. If you have another type of comment, leave it in the comment section. If you hate my videos, definitely leave a comment. See you guys in the next video. Watch and learn.